Conserving water for irrigation is a problem that's been tackled in many ways, but probably the most successful method is controlled damming. Water for irrigation can be stored in dams like these. The nearest dam is a Keyline Dam, located at the highest suitable site in the valley. The dam in the background is at the lower boundary level of the property. This particular irrigated hillside was sown under drought conditions and watered 3 times from a Keyline Dam before rain fell. This pasture was also irrigated by the dam, and these cattle have grazed here for 10 days. Now, let's build a dam, a Keyline Dam. It must be located as high as possible, but still have enough induced catchments above to provide a runoff to fill it. The dam will be built with earth from the valley. First we take some measurements and then plan the dam on paper. The first peg marks the saddle point. A levelling instrument is essential for dam construction. The one we use is the bunyip level, designed especially for farm work and is very simple to use. To check the level, press the atmosphere buttons and see that the water movement corresponds with movements in level of the staffs. From the saddle point, we level down to the pipe outlet level, and it's at the saddle point, incidentally, that the dam will overflow into another dam in the opposite valley. This is a peg 20 feet below the high water level and represents the toe of the dam on the downstream side. From this peg to the saddle point is 512 feet, which will be the length of the dam. The valley floor slope, therefore, is 20 over 512, which is 1 in 25. Now this is a block diagram of our proposed dam and has been drawn according to the information that was obtained on the site. The blue shaded area is the high water contour mark, and the arrow marks the saddle point where we drove our first peg. The Graham plough, with one shank turned down and the rest reversed to give weight, now marks out the features that were pegged. You'll notice that the pegs are always replaced after the plough has passed. This is a practice that must be strictly observed throughout the construction of the dam. Starting at the saddle point, the plough marks in the high water contour right around the dam. From the centre point in the valley, we determine the centre line of the wall, and from this line we peg the back and front toes of the wall. When the plough has finished marking, the bulldozers take the topsoil off the areas which will be affected by our construction work. This is put to one side in windrows and will be replaced when the dam is completed. The area near the wall on the upstream side is called the excavation area. When the topsoil is stripped, we make a cut-off trench along the centre line across the valley floor. This forms a base for our wall and is designed to key the wall into the valley floor. The floor of the cut-off trench is roughened up to assist bonding. Here we see a cross-section of our wall. It will be 270 feet long and 20 feet high to the water level at the centre, plus 3 feet freeboard and 2 feet shrinkage allowance. The cross width at the base is 100 feet, tapering off to 12 feet at the crest. The batter slope, therefore, is 1 in 1 3/4. The shaded area at the bottom of the wall is the cut-off trench. Now, when the cut-off trench is finished, we dig a trench for the lock pipe. The floor of this trench is also roughened to assist bonding. The lock pipe is laid usually a little to one side of the centre of the valley floor. The pipe must be laid dead straight and level, hence the trench at the upstream end may be several feet below the original level of the valley floor. These bulldozers are collecting earth from the excavation area for use in building the wall. This is on the upstream side of the wall. The baffle plates which support the lock pipe must be properly sighted and laid. This is so that the pipe will be dead straight and level. These pipes weigh about 700 pounds and are in 30-foot sections and are 8 inches in diameter. They can be handled quite easily and are quite sturdy and take a lot of rough handling. As an anti-seep precaution, a rubber gasket is fitted in the baffle plates. When the pipe is laid, it's about 2.5 to 3 inches above the ground. Hence, the bolts for the pipes can be easily fitted. It's most important that the bolts on the baffle plates are thoroughly tightened, or the gaskets will not do their work. A little earth is now brought into the trench by the bulldozer. This is just sufficient for hand packing underneath the pipe. We've found that 2 men hand ramming at an oblique angle pack the earth quite satisfactorily. Another anti-seep precaution is in the form of a powder called agyo. It's a very light powder made from expanded volcanic rock. The theory is that if water does seep around the pipe, the powder will move with the water and seal any leak automatically. We check the firmness of the packing by digging a small hole near the pipe. If we are satisfied, then this completes the handwork, and the bulldozer will finish the rest of the job. The trench is gradually filled in by the bulldozer until it straddles the pipe, but does not actually touch the baffle plates with the undercarriage. This operation doesn't actually compact the earth, but it does give it a uniformity of texture. Unless precautions are taken, the ends of the lock pipe may be lost. We mark each end of the pipe with a large oil drum and a post. The lock pipe system has been used by us on our own demonstration and experimental farms for 13 years. We've devised this present technique so that any farmer and an assistant can make a dam to professional standards. Now the wall of the dam is beginning to take shape. The fact that the inside end of the lock pipe trench is several feet below the valley floor means that we may excavate down to this level and use this earth to build our wall. This represents 5 or 6 feet of earth, which rapidly increases to 10 as we go up the valley. On no account dig beneath the level of the base of the wall. For high efficiency bulldozer operation, work on straight lines at right angles to the wall. Bulldozer operation efficiency can also be increased by grabbing a load quickly and going forward in second gear. On the empty return run, the back ripper loosens the soil for the next load. We struck rock in a few places, and in others the soil was very dry. Rock should not comprise more than 25% of any load. The batter must be trimmed constantly. This precaution is necessary so that if it rains during the construction, the smooth wall will not absorb moisture. The waves created by the bulldozer readily absorb water. Therefore, it is important to level and smooth over the walls last thing on any day. Otherwise, work will be delayed. Any water that does collect in the dam can be run off through the lock pipe. The whole of the operation must be under tight control, with the farmer checking the bulldozer work closely. This is the back toe of the dam and is nearly ready for final shaping. Be careful when working near the pipe opening to have somebody move the drum and clean around the pipe after the bulldozer has passed. The walls are checked for batter with slope meter and bunyip level. The batter is even on both sides, but the wall is shorter in the front than at the back. Now the reason for this is that the shorter length of earth will not slump so readily as the longer side. Once the walls have reached the required dimensions, the topsoil can now be replaced. This requires a little extra skill from the driver, for it's far easier to take soil off than to replace it evenly. When this is done, the surfaces may be smoothed over. We've found that a single cable dragged by 2 bulldozers, one on top of the dam and the other at the bottom, will smooth the wall over quite satisfactorily. The soil on the top and sides of the wall should be treated the same as a pastured paddock. A good pasture and soil on the walls will insulate them against the weather, and they'll not dry out. These surfaces are going to be grassed over and superphosphated. This is the entry cone for the inside or upstream end of the pipe. It's covered with heavy gauge wire mesh to keep it free of debris and has an upward tilt so that in the event of wall slippage the pipe will not block. The speed of the water through the pipe is 9 times greater than at the point of entry. This means a free pipe at all times. Now we fit the outlet valve. This has been specially designed so that the water cannot be turned on or off too quickly and so produce water hammer. At the side of the valve there is a small cock from which water can be drawn even though the main cock is off. Our dam is now complete. Only 2 jobs remain to be done: the construction of a feeder drain and an irrigation channel. Under Australian conditions, the conservation of water presents a problem which only ingenuity and hard work can solve. There are not enough experts to do all the work, therefore the farmer must do some of it himself. And we hope that this film will assist farmers to supervise their own water conservation scheme.